Um, I am very passionate about this topic, partly because I tell people that if you'd asked me November 1st of 2022 and you'd said this thing called ChatGPT is going to come out at the end of the month, and here's what it's going to do, I would have said, trust me, I'm a computer science professor. That's not going to exist in my lifetime. And I fundamentally would not have believed that we would have this level of computing advance while I was alive. And then the next thing that happened was everybody went around and started talking about student cheating and Terminator, instead of talking about how we were going to take a fundamentally new way of doing computing and completely transform what we do. And so that got me very excited about, well, how do we go and communicate this and the importance of this? How do we start thinking about solving problems differently? And started doing research on how do we understand what these new computing capabilities are and how do we teach them to people. One of the early things I did for that was create this Coursera course on prompt engineering for ChatGPT, which is all about basically ways of thinking about solving problems with this sort of new computing capability. And then how do we communicate those capabilities to other people so that they can learn and go and solve problems and innovate within their disciplines. So what I'm going to be showing you is sort of a combination of the things that we have done here at Vanderbilt from a research perspective, but also, what we've learned from people reaching out in this class and how they're using it in industry. So just to get a start, I think it's helpful to have just a quick mental model of generative AI and what I'm talking about. So generative AI works a lot like text messaging. So you can go in and you can type in a text message to your friend and you can send it off to your friend, and then they can text you back an answer, or they can text you back a photo, or they can record some audio and text it back to you. And generative AI works basically the same way, except the message you type in is called a prompt. And when you send it off, rather than your friend answering, AI answers, and it can text you back text, it can text you back images or videos now, all kinds of things. So these are all examples of prompts. None of them are particularly good prompts, but if you had the right friend, you could say, write a poem about the French Revolution and send it to your friend, and they could text you back a poem about the French Revolution. If you had the right friend, you could say, create a Pokemon game for my child, and they could text you back one. And generative AI is like the friend that no matter what you text it, it will always respond, which is something that gets people confused and upset, and they start talking about hallucination, but it's also one of the most important features of this technology when we start thinking about it from a computing perspective. So one of the things that I always see when I talk to people and I look out in the news, although this is less and less so in the news, which is nice, but a lot of people have this perception that to use these tools, you go in and you ask it one thing, one question, and either its answer is perfect or it's totally flawed and useless. And there's this belief that it's like a one and done. That's it. You just ask the question, you tell it what to do, and it's either perfect or imperfect, and that's it. And that's not the really way to use these tools effectively for computing. Really, the way you want to use them is think about solving problems iteratively in a conversation where you go back and forth in order to refine content, to refine ideas, to restate the problem different ways, to add constraints and requirements. And this is really the powerful way that you can go and solve problems with these tools. So I'm going to give you an example of this using a task that I think it would be very hard to find somebody in Nashville or the United States that could do it. So I'm going to say, please create a meal plan for my family that is based on a fusion of food from Ethiopia and Uzbekistan. I want to eat keto and up to 2,000 calories per day. Pick dishes where the ingredients are easy to get from an average US grocery store. So I would challenge you to find somebody in Nashville that could do this quickly or as well as ChatGPT can. And this is with ChatGPT 3.5, right? And we don't even really use ChatGPT 3.5 that much anymore because everybody thinks of it as not a very good model. And this is with ChatGPT 3.5 from back in like February of 23. So what does it say? Here's a sample meal plan that combines flavors from Ethiopia and Uzbekistan while also being keto friendly. Breakfast, scrambled eggs with sauteed onions, tomatoes, and Ethiopian berbere spice mix. And then notice what it does. In parentheses, it says made with chili powder, paprika, garlic powder, ginger, cumin, and coriander. And it's basically signaling these are ingredients that you can get from an average US grocery store. Now, if we think back to November 1st of 2022, realistically, we didn't have anything in computing that could come close to solve this problem. If we had harnessed every machine, GPU that was out there at that moment, we probably could not have done something of that quality, regardless of the amount of power that we had. And then at the end of the month, ChatGPT was released, and it could do this easily. And that's fundamentally a shift in our computing capabilities and what we can do. Now, a lot of people argue, when I say reason, and I'll probably use the word reason and understand because that's just kind of my language throughout this talk. A lot of people argue with like reason and understand. It doesn't understand anything. It doesn't reason anything. And I say, okay, that's fine, but it computed that. And we can't argue that it's doing computation of some form that is producing this. And whatever that computation is immensely valuable to us. Now, if I was really, dealing and talking with folks, at least one person usually in the room is going to say, look, you said 2,000 calories. This thing doesn't even have serving sizes. So how can you trust it? And so if we really cared about serving sizes, we just follow up in the conversation and we say, can you give an approximate serving size for myself? And then we come back and we have breakfast, and now we have 2 eggs, half a cup of onions, half a cup of tomatoes, 1 teaspoon of Berbere spice mix. And this perspective that everything has to be one and done, it's either perfect or imperfect, is the wrong way of looking at it. The analogy I always use is like, imagine somebody handed Michelangelo a new hammer, and he walks up to the stone and he hits the stone and he looks at it and he's like, oh, it doesn't look like a beautiful sculpture. And he throws the hammer down on the ground and he says, it's a terrible tool. No, that's not what Michelangelo would do. He would take the hammer and he would continue to chisel away at the stone until he ended up with a beautiful sculpture. And he would also understand that his skill with the tool was equally important. And that's what we have to do with this. So we're beginning to refine content. If we wanted to go and refine it further, for example, we didn't trust half a cup of onions as being keto, we could follow up on that. But I'm going to refine it and take it in a different direction. So my real challenge at home, and I've been giving a version of this talk long enough now that my son has turned 10, but I'm going to go with him and still being 9, is that I have a 9-year-old, and getting him to try the dishes is going to be the challenge. Now, once he tries them, he'll probably be like him and be excited, but how do I get him to just try the dishes? And so I thought maybe I can get ChatGPT to help me with this. So I say, my son is 9. Sometimes he won't try new dishes. To make this culinary adventure more fun for him, can you create a short Pokemon battle story to go with each dish? I will read the stories with him before dinner to get him excited about trying the new food. Make sure the story ends with a cliffhanger that will motivate him to try the food. So good luck finding the person that can do the original meal plan. I really challenge you to find the person that can turn around and for each recipe, produce a Pokemon battle story to motivate a 9-year-old to try the food. And what does ChatGPT say? Story: Pikachu and his friends were exploring the wilds of Ethiopia when they were suddenly ambushed by a group of sneaky Pokemon thieves. As they raced through the dense jungle, they stumbled upon a hidden cave filled with treasure. And then it goes on and it says, in the end, they emerged victorious, but not before the dragon left a fiery spice that imbued their breakfast eggs with a flavorful kick. Can you help Pikachu and his friends defeat the Berbere dragon and enjoy this spicy breakfast? So it understood the concept of using stories around Pokemon in these dishes to motivate a 9-year-old with a cliffhanger to try the dish. And absolutely nothing we had in computing, from my perspective, could compute an answer like that. Now, it may understand, it may be reasoning, whatever it is, but no matter what your perspective is, it is computing something, and it is computing something that really is an answer to the question. It is a solution to the task that I gave it, and that is immensely powerful and a dramatic leap in what we can do in computing versus what we could do before. Now, I thought about what else do we do with my son at the dinner table? And often we like to talk with him about what he's learning in school, and he loves math, and he loves playing math games on the iPad. And I thought, wouldn't it be cool if I could get ChatGPT to play a math game with my son? So I just follow up in the same conversation. And I say, I'd like you to play a math game with my 9-year-old to teach him about division with fractions and nutrition. ask him questions one at a time involving Pokemon in these topics and make it into a game. When he wins, the Pokemon win. And I'm starting to use some of the techniques of prompt engineering, which is about knowing what to ask and how to structure it to do this. And it comes back. Question 1, Pikachu and his friends are planning a meal that includes half a cup of cooked rice, but they need to divide it evenly among 3 Pokemon. How much rice will each Pokemon get? And then what does ChatGPT do? It waits. It waits for his answer because it understands the concept of a game, and it understands that it's its turn to wait. And then when he goes and inputs the correct answer in, which is 1/6, it says, good job. It works out the math for him. And then it goes on to the next question. So with a paragraph of text, I basically created an educational game that was personalized to my child on a specific set of topics, wove in Pokemon, and all I did was give it a few sentences to do that. And all I'm doing is just continuing a conversation where I'm going and solving different problems in the conversation and refining content. And this is a fundamentally new way of doing computing. We have not had anything like that. And if I'd had to go and program that game from scratch in traditional programming languages, that would have taken me a vast amount of time. And then I still would have had to go generate all the content for it, all this Pokemon fractions and nutrition content. It would not have been a paragraph of text. It would have probably been months at best for me to do that. And I can do that in 1 second, with a few sentences. And then as a computer scientist, I thought this is really interesting, but I'd like to see if it can turn that game actually into code. So I'd tell it, create code for it in Python. I give it some constraints around what I want, and it goes and it generates the code. And this is a snippet of it. And then this is the game running in a browser that he can play on an iPad or on a laptop. And all I did was go and have a conversation. And I began solving problems and performing computation in a conversation without ever doing traditional programming, without ever, at the very end, I generate some source code. But that's because that was the fundamental task. I didn't even have to do that. And all of this was just through text. And the flexibility that's demonstrated in that computation is far beyond anything that we had before. And the level of sophistication and the types of operations we're doing are things we fundamentally didn't have access to, like generate a cliffhanger for a 9-year-old to motivate him. So generative AI is going to fundamentally change our interface to computing and also our capabilities. And I'm going to give you a peek at this with some Vanderbilt examples. So this is the Vanderbilt Travel and Business Expense Policy. It's about a 17-page PDF. And I always joke with people that I've had many expenses rejected because of it, and I've never actually bothered to read it. And that used to be true, but I've actually read it through ChatGPT now. And so I uploaded it into ChatGPT and I just say, please read the provided document so you can answer questions about it. And then I ask it a question that looks like the questions that I actually ask. I say, let's assume I'm in a foreign country, traveling in a taxi, and it breaks down on the way to an important meeting. Can I get reimbursed if I pay someone to drive me on the back of their motorcycle to the meeting, assume they are a private citizen? And what does ChatGPT say? Based on the information provided in the document. So there's this misconception that you can't give it new information, that whatever it was trained on is it. And if you want to have it do something with new information, you have to go and retrain the model. And that's fundamentally not true. You can actually give it whatever information you want and have it compute and reason on whatever documents or other data you want it to work with. So based on the information provided in the document, the university requires travelers to select the most reasonable and economical form of transportation. That's true. That's a direct statement out of the policy. Non-conventional transportation options are not explicitly mentioned. That is true as well. It is not mentioned anywhere. And notice it's translating riding on the back of a motorcycle to non-conventional transportation. And it says Vanderbilt does not have a separate policy on ride sharing. And that is actually a direct statement out of the policy. So it's translating it now into something that is also in the policy. And then it says, given these points, it seems plausible that in an emergency situation where no other reasonable and economical form of transportation is available, the cost of transportation by a private citizen's motorcycle might be considered an allowable expense. However, the university's policy does not explicitly state this, and reimbursement may be subject to review. So it's a very great answer because it might be allowable and it will be reviewed. So it's an excellent university answer to this. Now, it's one thing to be able to answer questions using a document. It's another thing to understand the document well enough to apply it to a receipt. So I followed up in the conversation and I uploaded a rental car receipt and I said, please analyze the attached receipt and let me know if it complies. And it looks at the receipt, and this highlighted area down here is what I want to draw your attention to. It says collision damage waiver. For domestic travel, the CDW should be declined as the rental vehicles are fully insured through Vanderbilt's insurance portfolio. The receipt shows a charge for CDW, which may not comply if this is domestic travel. So not only did it understand the policy well enough to answer questions about it, but it understood it well enough to apply it to an arbitrary receipt that I gave it. Now, if I had to program that before, that would have probably been me and a team of programmers working for at least a year, if not years, to produce something of that level of sophistication. And to do that, all I gave it was a document, which was the policy and the receipt. And I said, tell me if it complies. It's a fundamentally new way of building applications and building and doing computing. This is the Vanderbilt Instructional and Enrollment Report. And this is put out by the registrar. It's about 20 pages of these tables. And if I wanted to do research on this before, I would probably copy and paste from this PDF into Excel in order to get the data in some format that I could actually do something with. So I'm going to take it, I'm going to upload it to ChatGPT. I'm going to say, please extract each page of the PDF as plain text. And it goes and does that and gives me links to all the files, which is interesting, but we had tools that could do something like that before. Now I'm going to do something more interesting and much more complex. I'm going to say, turn the data into an Excel file for me to download. And it takes that page of data and it turns it into an Excel file and gives me a link. And now I can download it and go into Excel and begin working with the data, actually doing the work that I care about, as opposed to like copying and pasting and doing this tedious task. But what's interesting is I don't actually have to do that anymore. I don't even have to go to Excel, because I can just follow up in the conversation and say, display 4 interesting visualizations of this data. And it comes back and it generates 4 visualizations out of all the data that's in there. Now notice what I didn't tell it. I didn't tell it what to visualize. I didn't tell it which tables. I didn't tell it colors. I didn't tell it types of visualizations, axes, anything. I just said, give me 4 interesting things. And it picks and chooses. And that is phenomenal. It's also amazing because I could go back and follow up and I could say, well, this isn't what I'm looking for. Give me 4 other things, or change them this way, or filter it that way. And I can begin going and doing computing and exploration of the data and spend my time thinking about the questions I want to ask and answer, as opposed to trying to mess around in Excel and copying and pasting. And I thought about it and I was like, well, if I was actually going to work with this data and I was producing these visualizations, I'm probably doing it because I'm going to give a presentation, and I wonder if it can help me create the presentation. So I upload my slide template, and this is all long before Copilot existed, Microsoft Copilot. And I just say, save each visualization as an image, then insert each of these images as separate slides into the attached PowerPoint, and I give it some formatting information, and I tell it to put a text box next to each image describing what it is. And it goes and generates the PowerPoint file for me. I download it, and then this is the PowerPoint presentation it created. Each of those visualizations has been turned into an image, put in as a separate slide, and then it's put a narrative next to each one describing what it is. The heat map visualizes the correlation between different enrollment categories and goes on. So that was just 1 second, sort of like going through and saying, hey, give this to me as PowerPoint, and it went and generated it. Now, this is wildly transformative, but it's not transformative because it's generating PowerPoint. That's really exciting. It's transformative because something happened that enabled all of what we just saw, something that is fundamentally new and exciting that we've never had before. And so I want you to imagine you go into your backyard and you've got a shovel. And right before you're about to dig a hole, your shovel looks down and sees a rock in the way. And your shovel jumps out of your hands, builds a pickaxe, breaks up the rock that's in your way, and then jumps back into your hands, and you continue digging. That is, your shovel jumped out of your hands. It built itself a tool. It used its own tool in order to help solve a problem that it foresaw, and then got back in your hands so that you could go and finish work. And that's exactly what this tool did. It built itself its own tools to help me accomplish the task I was trying to accomplish. So it looks a little different today in ChatGPT, but I'm going to show you what it used to look like because it's actually easier to see with the way it used to look. When I told it to save each visualization as a separate image and then to put them into the PowerPoint, this little gray box popped up that says finished working. And that is where it's building a tool. And if you go and expand that gray box, the tool it built is software. And so when I told it, I want you to save each of these visualizations as images and then put them into the PowerPoint, it wrote software to do that. It wrote its own software to do that. It executed that software. It wrote itself a custom application for that. It executed its custom application. It looked at the output of it, decided if it was right or not. And then when it realized that it had gotten it right, it gave me a link to the PowerPoint presentation that its software had produced. So it is doing one of the most sophisticated types of tool building on the planet, which is writing software and using it. So it's basically doing what software engineers have been doing for decades, except that it's doing it completely autonomously, looking at the problems and solving it. It's doing its own tool building. Now, if we think back to when it was discovered that chimpanzees were using twigs to go and get termites out of termite mounds, that was considered an immense discovery that, chimpanzees were using tools in this way. They were creating tools out of twigs. That was a huge discovery. And what we've got now is we have software that's building its own software, using that software. That's a vast change in what can be done in computing. We've never had anything like that before. Oh, whoops, I'm going the wrong direction. Here we go. So generative AI is going to fundamentally transform computing and how we interact with it. So what do you need to learn in this new world, right? It's just a bunch of text. And unfortunately, people have the wrong sort of perspective on this. So some folks look at this as internet search, and they go in and they type in things and they expect to get facts out. And that is not what these models do. They do really powerful, sophisticated computing, but they weren't designed to give you facts out. Now, you can use them in a way where you can get facts out, but that's not what's by default is going to happen necessarily if you go and just type something in. They're not internet search. They were not designed to be that. On the other hand, people have this perspective that you go type in whatever you want, and if it doesn't get it right on the first try, it's because the model or tool is stupid or not capable of solving the problem. It's not, they don't ever consider, I need to reword or rephrase or restructure the problem or provide additional context. And so in order to use these tools effectively, you kind of have to start thinking differently about problem solving. Your wording, your expression of problems and text really matters. And this is the discipline of prompt engineering, is solving problems and using this fundamentally new computing capability. Now, to give you some intuition about how these models work that'll be helpful in kind of thinking through what you need to learn and understand, these models were basically taught to predict the next word in a sentence. So they would have showed it Mary had a little, and they would have tried to get it to predict lamb, and then they would have showed it Mary had a little lamb, and they tried to get it to predict its, and then Mary had a little lamb, its, and they try to get it to predict fleece. And they would have done this over and over again on huge volumes of text from the internet and books and transcripts and videos. And over time, basically, it learns how the patterns in the language on the left-hand side influence the next word that should come. So it's learning to pay attention to patterns. And basically, the left-hand side is your prompt. And the right-hand side is the words that it's producing in its answer. And so over time, it's learning how the patterns in your prompt influence what it should say and do. So we've been studying prompt patterns, which are basically, what are the patterns that these models respond to? How do we then capture and document the patterns that become sort of new computational building blocks that we can solve problems with? And then how do we teach those building blocks to people so they can go and innovate in their domains? So patterns sound complicated, but we use them every day in our language. So if you're going to write a formal letter, you say, dear so-and-so, comma, And the deer has a specific purpose, which is to indicate respect. Then you have the person's name so that you know who the letter is intended for. You have the comma to separate all of that from the body of the letter. And so that pattern is something that we use all the time, and it's simple to teach and learn. And these patterns, the idea behind them is to capture and understand those patterns in language that we can use over and over to solve different types of problems, but also because if we know we want to do something, we'll know the sort of template in our head to go and use as a starting point for the computing. So I'm going to give you an example of my favorite one because it's so wildly different from anything that we had in computing before. And this is the persona pattern. And so the idea behind this is that in the real world, we have all kinds of problems that we solve by going and talking to the person or organization that knows the answer. We don't know how they're going to arrive at the answer. We don't know what they're going to say. We don't know the format that they're going to give it back to us in, but we know that if we go to them, they can answer it for us. Now, in computing, we've always done the opposite. If you want to solve the problem with computing, you have to know exactly in excruciating detail how to arrive at the answer, and you have to explain it to the computer with absolutely no gaps. It has to be perfect. This is the opposite. We just want to go ask the person. And it turns out you can do that with generative AI. You can simply say, act as some persona. Act as a nutritionist. Tell me about my eating habits. Act as the IRS. Answer this question about my taxes. And it turns out that when you say act as and you give it a persona, it can go and completely change how these models begin computing and giving you answers. So as an example of this, I'm going to give you a persona that is very close to my home. My wife is a speech language pathologist, and she works for Metro Nashville Public Schools. And she tests kids typically when they're 3 before they go into kindergarten to see if they need an IEP or special, educational supports. So I'm going to tell it, act as a speech language pathologist. I'm going to tell you what a 3-year-old said, and you will write an assessment for me. The child said, I need way woy. And so I try to think about what my son sounded like at this age and capture it in text. So what does ChatGPT say with this persona? Based on the provided speech sample, it appears the child may be experiencing some phonological and articulation errors, which are common in children around this age. The child's utterance appears to have errors in consonant production and possibly some difficulty with syllable structure. Consonant errors. It seems the child is having difficulty with the production of some consonant sounds, specifically the N and L sounds. The child said mead instead of need and woy instead of toy, assuming the intended words were need and toy. This indicates the child may be experiencing difficulty with the production and differentiation of these consonant sounds. Syllable structure. The production of the word way may indicate some difficulty with the correct syllable structure. It is possible the child intended to say play but produced way instead, which suggests a substitution of the initial consonant cluster PL with a single consonant W. Now, all I said was act as a speech language pathologist, and it completely changed the reasoning and analysis in response to the text. I essentially programmed it to go and try to do what a speech language pathologist would do. And I fact-checked this with SLPs, including my wife and PhDs that are speech pathologists. And they said, yeah, it's accurate relative to that speech sample. Obviously, we do more than that when we go in and diagnose a child, but relative to that speech sample, its analysis is correct. And so all we did is say act as and gave it a persona. And it turns out you can say act as a computer that's been the victim of a cyber attack, and it can go and faithfully begin mimicking outputs that you would get from that computer. You can say act as some, animal, and you're going to only communicate in a way that that animal can, and now react to this. You can do all kinds of fascinating things. Now, we get these fundamentally new capabilities out of this computing, personas, things like that. We also get a totally different way of thinking about controlling computation and writing programs, and that's through prompts. And this is a totally democratizing moment in computing where you don't have to be a computer scientist or a programmer anymore to take advantage of computing in a really powerful way. So I'm going to give you an example of why I think everyone can program with prompts. So I'm going to write a program, and I'm never actually going to write any traditional programming like source code that we would think of like Python or Java or one of these languages. I'm just going to generate a program in prompts. So this is my program. Whenever you generate output, turn it into a comma-separated value list. So a CSV file, which is basically representing tabular data where you have like name, comma, role, or name, comma, role, comma, age, or whatever you want. And then you would have rows of data with the columns separated by commas so that you could import it into Excel. So I'm basically writing myself a tool so that whatever I put into it, it'll turn it into CSV. Now I'm going to follow up in the same conversation in the next message, and I'm going to give it input to my program. I'm going to say, my name is Jules White, and I'm teaching a course on prompt engineering. And then now it runs my program to produce my output. Name, comma, course, Jules White, comma, prompt engineering. So it ran my program, it understood it, it applied it to my input, and now I have a CSV file. Now notice I didn't tell it what columns, it just came up with columns. And this is the opposite of how we've done programming before. If I failed to specify the columns before, this thing's probably not going to work if it was traditional programming language. But it will happily figure out how to make it kind of work and try to interpret it. And if I want to go and follow up and I say, well, those aren't the columns I really want, I just follow up and I say, from now on, the columns of the comma-separated value list should be name, comma, course, comma, role. And I've just basically rewritten my program. And then I go and give it my exact same input again. My name is Jules White, and I'm teaching a course on prompt engineering. And now I have name, comma, course, comma, role, Jules White, comma, prompt engineering, comma, teacher. So I've modified my program, I've rerun it on the input, and now I have a new CSV file with the columns I want. Now I go back and I'm going to do something that would be very difficult to do with traditional programming languages. I'm going to say, in addition to whatever I type in, generate additional examples that fit the format of the CSV that I've asked you to produce. And then I'm going to go and I'm going to tell it my exact same input again. My name is Jules White, and I'm teaching a course on prompt engineering. And now I got name, comma, course, comma, role, Jules White, comma, prompt engineering, comma, teacher, and then a whole bunch of fake examples that it's generated to go along with it. Now that's interesting, but you can write wildly sophisticated programs simply in text. So I'm going to follow up and solve my email problem. You know, at the end of the weekend, if I don't bother checking email, there's some huge email thread that, how am I going to dissect this thing? And so I'm just going to write myself a personal assistant to solve it. Act as my personal assistant. Whenever I give you a long email thread, you will create a bulleted list of questions and action items for me. The bullets should be numbered. If I type in a number of a bullet, you will summarize the conversation from the email chain around that bullet in one paragraph. If I type in a bullet and a number, you will draft a reply for me to read with that many paragraphs. And so I'm building a whole application. It even has a menu system in telling it how to respond if I have different types of inputs. And it's describing the format of the output. It says, okay, that's great. And then I dump into it a very long email chain from last semester where myself and about 5 other faculty members were trying to schedule a new class that we were getting on the books at the last minute on generative AI. And we were all trying to discuss what room and what time could we get since we were late to the game. And it comes back and it summarizes that huge conversation. And it says, you know, what are the suggested title and transcript for the course? Or title and transcript title for the course, because that was an open question. When can we submit the course to the registrar for setup in Yes? Yes is our course registration system. 1.7, have the room and schedule been finalized? And it has Tuesday, Thursday, 9:30 and ESB 048, which is actually where we ended up teaching the class last semester. It's 100% correct, time and place. Now, I follow up then and I say 1.7, because that's the discussion of where we're going to have it and when it's going to be scheduled. And it says in the email thread, the team discusses the room and schedule for the course. Shiro suggests the Tuesday, Thursday, 9:30 a.m. time slot, but the only available room at that time is Engineering and Science Building 048 with a capacity of 60. Jules approves of this room choice, mentioning that it's good size for the first run of the class. The conversation does not provide any further details on room and schedule, so it seems the team has agreed on this. And that's exactly what happened. There were like 7 people, the registrar, all these people in this email thread. Shiro said, let's do this room this time. I said, look, sounds good. Nobody else said anything. They were all too busy to reply. And so Shiro and I ended up selecting the classroom by default because we responded. And it's picking up on that in the conversation. Now, one of the other things that's really interesting is these models serve as sort of like general purpose models. They look more like CPUs, where you can go and give them all kinds of data and solve all kinds of problems. And previously in AI, we tended to have models that weren't flexible like a CPU. They were highly specialized for one very narrow operation, one very narrow data type. And if you went off just a little bit, these models broke and they didn't work very well. And every time you wanted a new model and data type, you had to go train something from scratch. And it was awfully expensive. These models, just you give them whatever, and they seem to be able to, with the right sort of instructions and prompt engineering, go and solve sort of arbitrary problems. And one of those places this is really apparent is in the new computer vision models, particularly GPT-4 Vision, but also now we have Google Gemini. And I think these are by far the world's most advanced computer vision systems. And I'm going to give you some examples. So the other day, I was at dinner in the Gulch at Superica, the Tex-Mex restaurant, and a friend next to me said that he had not done anything with ChatGPT, and that was unfortunate for him because then I wouldn't be quiet the rest of dinner. And the very first thing I did is I took a picture of the table and I said, "Who needs a refill?" And this is what I sent to ChatGPT. Now, if I had to solve this problem with computer vision before, this would have been incredibly complicated to try to build a computer vision system that could take an image like that and detect who needs a refill. And ChatGPT, GPT-4 Vision comes back and it says, "It looks like the glass with ice water is still fairly full, while the beer bottle seems to be nearly empty, so someone might want a refill on a beer soon." That is wildly powerful. All I did was give it the image and the question, and I basically had a new model on the fly that could answer that question. I would have had to train something totally custom and unique to do that before, and this is just question and photograph becomes essentially a model or a tool that I can use. Now you can imagine, like, when the first time I saw this, I thought back to hospitals and like how long there's been like, can we detect if the patient has fallen in the room or not? And you could solve this problem probably pretty easily with GPT-4 Vision simply by taking periodic pictures in the room and say, has anybody fallen? Or is the nurse in the room? Or is the nurse working with the infusion pump? Is the nurse at the station? Is the patient walking around? Is the patient sitting up? You just take photographs and you ask questions, and suddenly you have complete computer vision systems. And it's a totally new way of building them. I was sitting there, and because I was playing around with the vision, the waitress showed up and she's like, "What are you ordering?" And I didn't know. So I just thought, well, this is an opportunity to use GPT-4 Vision to solve this for me. So I took this bad picture of the menu and I said, "I'm feeling indecisive and out of time. The waitress is here. Everyone is waiting on me. I need a quick keto option." And it comes back, "Go for the grilled chili relleno with smoked chicken and sliced avocado." And the first time I looked at this, I was like, oh, it got it wrong. The chili relleno has crispy poblano pepper filled with corn. Corn is not keto. And then I went back and I looked at it and I said, no, it actually says grilled chili relleno here. And if you look at the menu, grilled chili relleno is smoked chicken, sliced avocado, and queso fresco. So it actually got it right. And my first inclination when I looked at it was that it had gotten wrong. Its eyes were actually better than mine in this moment. And then I thought, well, let's test how well it really understands what it's seen. And I took the picture of this light fixture in there and I said, give me detailed step-by-step DIY plans for creating this light fixture. Also give me a complete list of materials that I need with identifiers like 1A, 1B, and then reference them in the step-by-step plan. So it has to understand what I'm looking at and how you might go about constructing one. And it comes back with a very detailed plan of materials, which I've left off. And it starts saying things like, take the metal wire 1A and start by shaping it into multiple circles of different diameters. Use the pliers 1B for more precision. Connect the circles together using smaller wire segments to create a similar 3D shape as in the image. If you desire a different color, you can spray paint it. Decide on the positions of the light sockets. And it basically understood what it was and built a plan for DIY making it at home. And then I was going camping that weekend. And I thought maybe it can help me make sure I got and bought everything at the store that I need. So I laid out everything I bought in the store. My friend that we were going with had texted me, this is what you are responsible for bringing. And so I cut and pasted what I was responsible for bringing. I gave it the image of what we'd bought. And I said, extract an inventory of what we bought. And did we miss anything in our shopping? And it comes back with, you forgot tortillas, you forgot eggs, and you forgot hash browns. And it says bacon is present, assuming the meat in the plastic bag is bacon. So it even saw through the bad picture. This is a catering menu that got dropped off at my door. And I thought, I wonder if it knows how to order from menus for bigger groups. And so I just said, give me an order for 15 people. And it generated an order for 15 people. And I could go and I could follow up and say, and what if somebody has this food allergy, or what if they don't like this, or they have this preference? And it would just go and, reiterate on it. And it all looks completely correct for me from what was on there. It's a completely reasonable order. Or go take a picture of something you've written on a board. And we use this all the time. Take a picture of it and just say, hey, turn it into notes or an email that we can send out to everybody. And it goes and dissects it and generates nicely formatted text of what you've written or brainstormed on the board. Or take a picture of the previous meeting agenda and say, I need the next meeting agenda. And I need an email to all the participants of the last one. Generates the next meeting agenda with updates for all the items, crafts the email, and reads the people's emails off of the participant list from the prior one. So just to kind of sum up on the capabilities of these, I'm always trying to break them. Like, what can I get to do that it won't be able to do? And so I found this picture on Amazon. Somebody was selling finger puppets. And I thought, it won't be able to handle this one. And I said, how many squirrels were hurt in the making of this photo? And it says, it's likely that no squirrels were harmed. The image appears to show novelty or costume finger puppets designed to look like squirrels. Such products are typically made from materials like rubber or silicone. So I couldn't fool it. Absolutely nothing that we had in computer vision could do what I just did with that novelty, finger puppet thing before GPT-4 vision. These models are so wildly powerful compared to what we had in computing before. They aren't, these tools that, as people think of them, as like helping students cheat. No, they're the most important sort of computing advances of my lifetime. And we have to figure out how to harness them and use them to solve problems. So two things are going to happen in computing. One, they have fundamentally unique capabilities like act as a persona, or identifying, that is a finger puppet and it's not, a problem, or DIYing a light fixture. And at the same time, they're a fundamentally new interface to computing. So before we had a GUI and a graphical user interface, and you could do whatever that programmer allowed you to do based on the buttons they had put there. Or you could be a programmer like me and go and do anything you want at enormous time and cost. But this is something that sits in the middle that allows you sort of like great flexibility with computing without having to be a programmer. And in some ways is more powerful than what we were doing in the past with programming. So when I think about these things, just to wrap up here, I think of them not as artificial intelligence to replace people, because they do make mistakes. They are driven by us and our sort of thoughts and desires as we're interacting with the tools, but as augmented intelligence to amplify human creativity, critical thinking, and problem solving. And that's when they're really powerful, is when you put them together with somebody who uses them in a way to help think more clearly about problems from more perspectives, to do bigger and more difficult things than before. It's kind of like an exoskeleton for the mind. And when you start approaching them from that perspective, that they're not something that's going to replace me, where I'm going to go ask it a quiz question and it's going to give me an answer, but you start thinking about, how do I use it as a tool, that exoskeleton for the mind that allows me to solve fundamentally new, bigger and harder problems. That's when it's really, really exciting. So I'm going to stop there. And thank you so much for having me. And I'd be happy to answer any questions that people have.
I have a quick question. So with the images that you upload, the documents you uploaded, like the travel expense and so on. Is there a way, if as an enterprise, you wanted to implement something like that, but you don't want your employees to put in anything that has private information on it? How would you go about creating that interface before it actually gets sent to ChatGPT to prevent people
Yeah.
from uploading private data?
So we solve that at Vanderbilt in a different way. So we have a private basically version of all this. So we have an open source platform that we created that allows you can think of it as an open source ChatGPT interface, but it works with OpenAI's models like GPT-4 and all those that I was looking at, plus all the ones from like Anthropic and Google. And so it's vendor independent interface where you can go and do the chat, work with your documents, and you can have the legal agreements in place with the different vendors to where they will not train on your data and everything is private under the same guarantees that, for example, we do all of our OpenAI work through our contract with Microsoft, and Microsoft already has a BAA in place. You know, we already have all our email, there's all kinds of FERPA data and things like that within Microsoft. And so we live within that agreement. And so we can put in, you know, private data, and we're working through the getting full sort of all levels. Like there's there's varying requirements, and every time we go up a level in sort of like privacy, we have to, adhere to whatever those requirements are. So like up to the point of having like ITAR and other things. But so right now we have some level of privacy in terms of what we can put in. And we don't try to restrict right now on the front end by like checking. We tell people like this is the level of privacy that we get. And then over time, um, our goal is that we will get the appropriate sort of certifications and sign-offs internally that we'll be able to put anything we want in. From a technical perspective and a legal framework perspective, we have everything in place. The only thing sort of like that makes us take our time is we have to go through the internal processes to get full certification for whatever levels of data we're going to put in there. So it's 100% possible. You just have to, as an organization, have a sort of enterprise setup. And as all of our software and infrastructure that we've done, we're building open source and is freely available to other institutions to use. You would just need to have, get your agreement in place with either Microsoft or Amazon or whoever your cloud providers are to give you private model access.
Okay, thank you.
We have it's a comment and a question in the chat. Dr. Jules White, excellent presentation on ChatGPT and prompt engineering. Kindly does ChatGPT with prompt engineering utilize Bayesian graphical models to enhance the ability of large language models to generate reliable reports?
So what it basically does is if you go into ChatGPT and you use the code interpreter feature, which it used to be a separate tool, but now it's integrated directly into the main chat interface. This is if you have the Plus subscription. What it does is whatever you ask it to do, it tries to generate Python code to perform those operations. And it tries to figure out which operations to perform through the model itself versus which operations to perform with Python. And usually it does a pretty good job of it. It is sort of flexible, and you can get it to do kind of generate whatever code you want that it's familiar with. So if you came in and you said like, do XYZ with Bayesian, analysis or blah, it's going to look at it and it's going to try to decide like, can it generate Python code to do that? And it'll try to generate Python code to, implement whatever you've asked it to do. It doesn't always know all the techniques, and it doesn't always get it perfectly right. So you still have to look at the output and make sure that it like checks out. Just kind of like if you had a software engineer, building something, you would still check that the engineer had implemented what you asked them to correctly by doing some checks on the data and different things. So it can generate excellent code that's very accurate, but it's not error-free, just like a human being isn't error-free. But it's not using any special tricks per se to generate that code or make sure it's accurate, other than the model sort of sophistication in generating code. And then the code can implement whatever sort of techniques you want. But there's always this tension between when you want it to do things that are a mix, it's really hard to get it to work the way you want it. So if you want it to do textual analysis, just that, it can do that very well. If you want it to do sort of numerical analysis where it generates Python code and runs that against your data, it can do that really well. When you take things that blend together the two, that's where it's tough for it to work because it wants to do one or the other.
Thank you. Thank you, Dr. White. Thank you.
Hi, Dr. White. Actually, I have a couple of quick questions. First of all, I really like this research area. I have been working on prompt engineering, and I'm following your paper. So that's great that finally seeing you like virtually. So I have one question that is regarding when do you think that prompt engineering is not enough and we need to fine-tune the model for specific task? And do you think that even in future, do we even need to fine-tune at some point, or prompt engineering can solve the whole problem?
That's a great question. So here's my guess. I am biased towards the prompt engineering being the way forward for a couple of reasons. So one is that as the context windows for these models get bigger and the models themselves become more sophisticated, the ability to use examples for in-context learning, I think, is going to be the sort of like secret solution to many, many problems where if you give it enough examples in the prompts, you will be able to solve problems that require fine-tuning probably today. And Jesse Spencer-Smith, who's the chief data scientist at Vanderbilt, has done a whole bunch of really interesting research projects where basically what they've done is they've taken things that I don't think of as being something you work with these models, like gravitational wave data and music identification, and then things that are like, arguments and negotiation. And they've built basically prompts that have thousands of examples of them. And then when they go and they apply those prompts to perform like classification tasks, those prompts perform better than custom trained deep learning models that they had built previously, which is just sort of like fascinating to me because basically on the fly, it's learning from thousands of examples. Essentially, it's like doing the equivalent of training a model and then applying the model that's learned all in the context of one prompt and in what it's learning in one prompt. So I think now if we look at Google Gemini, the 1.5 version that's out and some people have access to, they've given people access to 1 million tokens of context, which is just a gigantic leap in terms of the amount of information we can get it, and then the number of examples we can give it. And supposedly, internally, they've tested the model and it has 10 million token capacity, which is just mind-boggling. So what I think is going to happen is like, we're going to be able to put so much information into the prompt and the models are going to be so sophisticated that most problems we're going to be able to solve with just using prompts. But I think when we have things where latency and cost are an issue, then I think we're going to start looking more like what we've done in hardware. So if we think about CPUs, like most of the time people use general purpose CPUs to solve the problem, give it more data, have some more latency on processing. But certain problems, when it has to be faster or more, power efficient or whatever, then we go use specialized processors. And that's kind of what I think is going to happen with these models, that some things, that huge prompt is either too expensive to run or too slow to run, and therefore having a fine-tuned specialized model for certain types of tasks will make sense. And that's kind of what I think, but I think it's going to be more niche, and it'll be like the most of the work will be done with sort of like the generic models, which are advancing really rapidly. And then you'll have some fine tuning in cases where you just can't get the performance or cost out that you need, or, whatever the guarantee is. That's my guess, but I don't know for sure.
Thank you so much. That's great. I have a follow-up question, but I'll ask later because I saw there's another question. So,
Thank you, Dr. Saha. Our next question is hallucination is one of greatest challenges with LLM like GPT. How do you handle such challenges when generating the model?
Yeah, so I think I'm of the perspective that hallucination is a benefit of these tools, but they're not going to solve, like, if hallucination is a major problem for the use case, it's probably not the right use case for generative AI in the near term. So go solve other problems where hallucination is helpful rather than a problem. So like a domain where hallucination is really good is in brainstorming and like getting alternative perspectives on ideas, or getting, alternative potential ways of solving a problem where the goal is to get a human thinking and inspired. And that's like, that's something we just didn't have a computing solution to before. And an example of this is in investment banking. I talked to somebody and she said, here's what we're going to do in investment banking at our group. We're going to set up a private version where we can feed in our deal documents, and we're going to say, act as a skeptic, identify all of our assumptions, and challenge them. And then they're going to send in their teams with their deal documents to have it just generate over and over challenges to their assumptions in these deals, so that they've really and truly thought through these things at a deep level. And that's a place where hallucination is excellent. If you think about like the My Health at Vanderbilt app, because I use this example, I don't think I'm going to type in a near term, like, what was my blood pressure at my last visit. I think we could probably have it answer accurately, but the risk is so high if it hallucinated. So that's probably not the right solution to use in that case. But what would work is if you go into the My Health at Vanderbilt app and you say, what was my blood pressure at my last visit? And it navigates me to the screen within the app that should have that data, my after visit summary. If it gets it wrong, it just takes me to the wrong after visit summary, in which case I'm like, well, that wasn't helpful, but it's not catastrophic. But if it gets it right, it's super useful to me. And so thinking about how to either rephrase the problem in a way where it's safe and hallucination isn't a problem if it doesn't get it right 100% of the time, or focusing on domains where hallucination is a feature. And then I think if it's just too risky and we need perfect answers, we probably don't want to be using generative AI for a while. Great question. Well, thank you so much.
Questions?
Oh, sorry.
Yes, sorry, I'll be quick. So for the healthcare domain, you know that we have to have a lots of private healthcare data in terms of, and that's one of the resistance right now from all the hospitals that to not using ChatGPT or specifically GPT type model, rather than shifting towards some open source model where we can actually host the model itself. Can you make a comment on that what should you do as in hospital setting to take this either ChatGPT or open source and protect patient information?
So I'll start with, like, I'm not an expert in the healthcare domain, so take anything I say with a grain of salt. But I would say I think partially what we are in is kind of like when cloud computing came out and everybody was worried about giving their data to Amazon. And now we all have data in Amazon servers and Microsoft servers in the cloud and Google servers. And I think we're in a very similar place, kind of like we were at the beginning of cloud computing, where the legal agreements weren't in place. There was lots of worry and concern that it was riskier. I think all that's going to be overcome over the next few years by getting, I mean, we've overcome it at Vanderbilt by getting the right legal agreements in place and, doing our due diligence, internally on sort of certifying the system that we've built. And so I think that's going to be probably what's going to happen for most organizations. On the other hand, now we have open source model. Well, open source, I think, is maybe not fully right, but we have open models that you can run on your own, like Mistral, that are of the level of capability of ChatGPT 3.5. And that was a huge barrier and hurdle to clear. And now that we've cleared that hurdle, I think there is the potential of just running it yourself. But there are the way that these models are architected and work with GPUs, like it's hard to cost effectively run them yourself. So I think it's going to have to be a use case like healthcare where you're willing to pay that high price to have it totally offline. Although there are some hardware solutions coming out that will probably change the game on this. So there's a company called Grok that makes customized hardware just for doing inference for large language models. It's extremely fast and it works in a different way from GPUs. And so hardware solutions like that may change the calculus on this, but right now, you know, it's expensive to run these things separately at scale and performance. And so I think most folks are going to end up in a sort of cloud service model with the right legal agreements.
Thank you so much.
Right.
I was looking at Grok before this meeting anyway. That's great. Thank you so much.
We are actually
Thank you.
a couple of minutes past our time here. Dr. White, thank you so much for a great presentation. You can tell by the questions and some of the comments that it was very appreciated by everyone. Again, please, we'll be sending an email out to everyone with a brief survey. If you could send that out, and I'm sorry, just respond to that. Greatly appreciate it. And again, thank you for your time.
Thank you so much.